To kick things off, we have David Norman, who will be talking about derived ornithopod dinosaur systematics.
Good morning. This is, I suppose the moral of this is don't assume you know too much, or perhaps I should know better. But I'm going to be talking about these sorts of creatures, relatively common or garden herbivorous dinosaurs, and in particular this sort of creature, this is Iguanodon itself, was something I studied too many years ago, and as a result of that early work back in 1980, I sort of came up with a very simple systematic pattern based on the few numbers of dinosaurs that were then known. And I'd just like to point out the general shape in the sense that it's, the two groups, Hypsilophodonts and Ontosaurus, just hived off to the left as sister groups of the other groups, which was my sort of gut feeling about the nature of the relationships between the organisms. It was a line of sight sort of systematics rather than anything more sophisticated than that. This was a long time ago. Since that time, that small number of taxa in that particular area of study has expanded extraordinarily. It's been a sort of huge plethora of these sorts of creatures, well in excess of 50 taxa. So that rather simple line of eye sort of pattern of relationships has been sort of overtaken by this enormous productivity of research in this particular field. So this has had an impact. It's had an impact at a taxonomic level because the sort of creatures that I was looking at were based in the Wealden. And as a result of the work that's been done at a taxonomic level, it would sort of appear that in the Wealden, if you take the interpretations of a couple of American research workers in particular, that there are at least 18 different taxa of this style of dinosaur living in the Wealden. So there's really quite a significant diversity at that time. On the left-hand side, there's a sort of more conservative view, which is basically mine, which is that there are essentially 4 quite distinct taxa. And the taxa on the right are really a basis of a poor understanding of the anatomy of the actual specimens in question, and their over-interpretation by people who want to introduce a lot of diversity into a specific time zone, because that time zone is broadly in comparison with time zones elsewhere, where there is a greater taxon diversity. So on the face of it, you do want greater diversity, but on the pragmatic side, do you actually understand the anatomy of these things in order to justify that taxonomic diversity? My skeptical view is no, we don't. One of the reasons why the Wealden is different from other areas, I'm particularly thinking about the Cedar Mountain Formation in North America, a slightly younger formation, but incorporating a similar sort of span of time, very approximately, is that the actual areas or stratigraphic horizons from which these things are collected within the Wealden succession are very limited. There are actually 2 primary areas indicated by those black bars, which are somewhere between 1 and 2.5 million years in span. And maybe it's perhaps unrealistic to expect there to be a significantly greater diversity of these style of dinosaurs, given that you're only sampling these 2 particularly narrow horizons within the overall Wealden succession. So those are sort of words of caution. So on the right-hand side, you've got those 4 taxa that I believe are the condensed version of the 18 taxa that have been described by other people across the last decade or so in particular. And they're based on quite reasonable anatomical material. There's this thing that you've just seen, Iguanodon itself. There's a contemporary form, Mantellisaurus, and these are both younger forms. These are from the top of the Barremian, lower Aptian. They're absolute contemporaries. Their bones are found alongside each other in various Wealden deposits across Britain and Europe. In the Valanginian, significantly earlier, there are again 2 morphological types, again robust and relatively gracile, and there are questions about what the significance of the gracility versus the robusticity is, but I won't go into that. There's this form, which is particularly robust, known as beryllium now, and this specimen known as Hypsilospinus. As you can see, there's a fair degree of skeletal representation within this. Not complete, but they're sort of interestingly distinct from the younger Barremian Aptian forms. What falls out of this sort of work is a very tedious sort of descriptive anatomy, which I've had to just do in order to justify the taxonomy, and then begin to look at the relationships between these organisms and the general pattern of systematic relationships. And in a sense, what you're doing is you're sort of reassessing what has become a sort of benchmark of the topology, the general pattern of relationships that have existed, in this case, since about the mid-1980s. And Paul Sereno's work has sort of tended to dominate in an interesting blinkered way, in the sense that he created a particular systematic pattern. It stayed in the literature as far as he was concerned without alteration, despite the contributions of other workers who suggested that actually the topology was incorrect for various reasons. So the general topology, which was this Henigian cone, is very persistent. It's continued right from the mid-80s through to essentially the present day, and has been followed by myself. Systematic revisions have tended to produce the same sort of Henigian cone. All well and good. So the review that I've done of the systematics and relationships of the organisms has led to this revised systematic pattern, and I really don't want to labour this too much. I just want to pick up those starred items here. The starred items reflect the fact that the Henigian comb is sort of, in a sense, being broken up a little bit, and it's sort of intriguing that this work has done that, because as in this very early work that I did, it's suggesting that these particular taxa, which include this animal called Hypsilophodon, as well as Tenontosaurs and a variety of diverse forms in the late Cretaceous, cluster together as a particular clade, and that clade, rather than being a sort of successional series leading up to the more diverse hadrosaurs in the Cretaceous, is a sister group to what I'm referring to here as the Iguanodontia. It's revising the sort of concept of these particular groups and their patterns of relationship. So what I just want to briefly pick out is that basal pattern. At the bottom, you've got what I've called clypeodonts, and I'll explain what that means. It's sort of to do with the shape of the teeth of these creatures. The Hypsilophodontians, these things here, and then the Iguanodontians. And I just want to sort of concentrate on those that basal split and the general topology in relation to the evolutionary history of the group. So the clypeodonts is this generalized group, and what I'm trying to do is distinguish these from the more derived forms of ornithopods. The clypeodonts are the more derived form, which are distinguished from these basal Neornithiscians. The general pattern of their anatomy is pretty much similar. They're either sort of they're all bipedal cursors generally, sometimes reverting to a more quadrupedal pose. But the crucial thing I just want to emphasize is that their dentition is pretty unspecialized, and the teeth are very simple and leaf-shaped, with enamel distributed on both sides of the crowns, not particularly differentiated, generalized herbivorous adaptations. By contrast, from that sort of generalized pattern of undifferentiated types of teeth, in the clypeodonts, as a group as a whole, you get a specialization of the teeth. And again, very briefly, what you get is enamel distributed primarily on one side of the tooth. The teeth are flattened, more they keep that sort of leaf-shaped orientation, but they also develop a series of crests and ridges. In this case, you've got a very prominent ridge on the lower tooth and a series of ridges on the upper tooth which face each other. But it's a very specialized tooth structure compared to the overall pattern of leaf-shaped teeth that you see in the more generalized forms. So that's one of, I think, the most critical changes. There are others as well. So within the lineage on the left-hand side, the Hypsilophodontians, there are an interesting range of creatures, more diverse than we ever thought before. This is Hypsilophodon itself, and I just want to emphasize again, they've got these clypeodont teeth, with this sort of asymmetric distribution of enamel and the ridges on the teeth themselves, and a fairly characteristic pattern of ridges, in that the lower teeth tend to have a very, very prominent ridge, and the upper teeth tend to be flat with lots and lots of little ridges. The femur, I'll just pick out some bits of the postcranial anatomy. They have this peculiar sort of sheath-like arrangement of ossified tendons on the tail. And the femur, just to get your eye in, does tend not to have a big slot-like groove in the front edge of the knee joint. The extensor groove. So it's a sort of, and that's a feature I'll just pick up in a moment. Related to these forms are a diversity of Zalmoxis-like creatures, the so-called Rhamnodontids. There's quite a diversity of these forms in the late Cretaceous. They have, although the picture, this is one of Dave Weishampel's sketches, doesn't really show it, they don't have much of a groove in front of the knee, but they have exactly the same pattern of teeth, but they're far larger. Again, with a huge ridge on the lower dentition, and this sort of lots and lots of little ridges on the upper dentition. This is the skull. The skull, just to make a little bit more of it, again has this very distinctive dentition pattern. It has a much longer snout and much deeper snout associated with larger size and herbivorous adaptations. And also it has this sort of triangulation at the rear of the skull, which is sort of, again, interesting as an overall observation because it seems to be consistent within this group of animals as a whole. If you extend through into the larger forms, these things like Tenontosaurus themselves are, again, distinctively similar, as it were. Although it's not shown here on this illustration, have this curious sheath of tendons around the distal end of the tail that makes the end of the tail very stiff. They have exactly the same style of dentition in terms of the ridging and grooving pattern that you see on the teeth. And again, they have this triangular occipital, rear part of the skull. Very, very, very distinctive. This is the side view of the skull. There are very distinctive aspects of the anatomy which I won't bore you with. Again, the femur has a shallow extensor groove on the front, and it's become very columnar. I just want to emphasise that just for the moment because of this possibility of convergence. And finally, within the Hypsilophodonts is this really enigmatic group. Please, Australian colleagues work on this. I went on an expedition here and found about 4 skeletons of this damned animal out on a farm. And the farmer wouldn't let us excavate them and bring them back to the Queensland Museum. This is a very large 10-metre plus ornithopod, very poorly known. It's got exactly the style of teeth that you find in Hypsilophodontians generally. We know precious little of the skull. It's got a lot of sort of intriguing aspects which might confirm its relationship with the Hypsilophodontians as a whole. The third section, you've got these clypeodonts with shield-like teeth, you've got the Hypsilophodontians with their own particular character complex, are contrasted to the general iguanodontians. These have very distinct teeth. They have, by contrast, a huge ridge on the upper tooth and very shallow ridges on the lower teeth. Again, they overall leaf-shaped, but very, very distinctive anatomy. They also have, just to pick out the femur, they have this distinctive groove on the knee. And they don't have this sheath of tendons surrounding the distal end of the tail. The tendons are just found over the back. It's a contrasting set of morphologies within, in this instance, small size range, very clear, similar to that of Hypsilophodon. Medium size range, things like these camptosaurs, exactly the same overall anatomy, same very, very distinctively distinct teeth held within all the iguanodontians. Same with the very large forms, exactly the same form of anatomy. So overall, what you end up with is small iguanodontians with a very distinctive type of femur, just with this very narrow slot, But in contrast, you've got things like tenontosaurs, which are medium to large sized hypsilophodontians, which don't have much of a groove on the front end of the knee, contrasted to a similar sized iguanodontian, which has this very deep slot. Maybe the illustrations don't show this as well as they should. The intriguing thing about this is that overall, you've got a series of parallel evolutionary traits. You've got the trend towards large size, and within that you've got convergent adaptations to do with the cranial morphology, the structure of the beak, the depth of the beak, the length of the beak, the structure of the axial skeleton, that way the hand and the limbs are built, and that these are all converging upon the solutions to large size in these dinosaurs, even though they're developed in independent lineages. There are divergent features which allow you to distinguish between the hypsilophodontians and the iguanodontians very clearly, so you can tell one from the other, but you can see that there are convergence trends within the two groups. This has to be followed up by a lot of future work in order to sort of quantify this more accurately, and also to tease out the various independent aspects of what appear to be a series of parallel and convergent trends within these two groups. I didn't expect this. I thought that my work would actually confirm the general Hegelian comb. The fact that there's more structure to this and it's actually showing a more complex picture, I think is quite interesting, and is sort of reviving my interest in this group as a whole. Thank you very much.